Welcome to the Automated Daily Space News Edition, the podcast created by generative AI. Today we're tracking a day in space news that stretches from the fate of the universe to the servers that deliver Earth observation data. We'll cover a new AI-powered cosmology result, a cinematic Mars flyby from NASA's Psyche mission, dramatic new astronomy highlights, launch schedule turbulence, and the digital tools helping scientists uncover hidden structures across space and Earth. This episode is brought to you by SurveyMonkey. Don't just know what happened, know why. SurveyMonkey can help you unlock insights by combining feedback with operational data to get vital context. Find the link in the episode notes. First up, cosmology. One of the standout stories is a new AI-driven analysis entering the dark energy debate. Building on massive survey efforts like DESI and Euclid, the result hints at fresh ways to interpret the large-scale structure of the universe and potentially whether dark energy is truly constant or evolves over time. That's a huge question, because if dark energy changes, the standard model of cosmology may need a serious update. Just as important, this story shows how artificial intelligence is becoming a core research tool, not just a buzzword, in the effort to understand cosmic acceleration. Next, NASA's Psyche mission has turned orbital mechanics into visual storytelling. The spacecraft has released a time-lapse of its Mars flyby, showing its approach, close pass, and departure, as it used the planet's gravity to reshape its path deeper into the solar system. Gravity assists are usually discussed in technical terms, but this update makes the maneuver intuitive and memorable. It also serves as a confidence check for the mission team, demonstrating spacecraft performance as Psyche continues towards its scientifically unusual target, a metal-rich asteroid that may resemble an exposed planetary core. On the astronomy side, NASA's astronomy picture of the day spotlighted NGC 3576, also known as the Statue of Liberty Nebula. Located in Carina, this star-forming region is packed with gas, dust, and at least dozens of massive stars nearing the late stages of formation. It's the kind of object that reminds us starbirth is not a quiet process. Radiation, winds, and feedback from young stars actively sculpt the nebula around them, making places like NGC 3576 key laboratories for understanding how massive stars form and how they reshape their galactic neighborhoods. James Webb is also in the mix again, this time with observations of an unusual galaxy apparently shaped by a cosmic collision. Webb's infrared sensitivity lets it peer through dust and pick out structures that can be hidden from optical telescopes, making it especially powerful for studying mergers and disturbed galaxies. These are more than pretty pictures. Collisions can trigger bursts of star formation, feed central black holes, and fundamentally alter galaxy evolution, so every well-resolved case helps astronomers connect theory to real systems. Back closer to home, another intriguing headline involves a possible giant impact crater spotted using Google Earth. The report highlights how satellite imagery and accessible mapping tools are increasingly part of the scientific discovery process, allowing researchers and even the public to flag circular structures that may deserve deeper geological study. If confirmed as an impact site, the feature could add to Earth's record of ancient collisions, helping scientists refine models of impact history, environmental disruption, and the long relationship between our planet and the rest of the solar system. At the opposite extreme of scale, astronomers have reportedly reconstructed the magnetic field of a galaxy cluster in record detail. Magnetic fields are often the invisible ingredient in big cosmic structures, influencing plasma behavior, particle motion, turbulence, and radiation. A breakthrough map like this can help researchers understand how cluster fields form, how they are amplified, and how they interact with the hot gas filling these enormous systems. It's another reminder that some of the biggest advances in astronomy now come from combining multiple data sets with increasingly sophisticated analysis methods. Now to launch operations, where SpaceX saw a Falcon 9 Starlink mission scrubbed from Vandenberg. In today's launch environment, scrubs are less dramatic failure than routine evidence that automated safety checks are doing their job, whether the issue is weather, range constraints, or vehicle health. Still, the event matters because it reflects the extraordinary cadence of modern launches, especially for mega constellations. On the same broader schedule are the MRV-MEP mission, likely tied to robotic on-orbit servicing capability, and Starship's 13th flight test, another step in the long campaign to make ultra-heavy, reusable deep space transport practical. And finally, a quieter but important operational update from Europe. ESA announced scheduled maintenance for several Earth observation data portals. It may sound mundane next to rockets and nebulae, but these systems are part of the essential infrastructure of space science. Platforms serving missions like Swarm, Cryosat, ALICE and SMOS support researchers working on everything from magnetic fields and ice thickness to atmosphere and climate. Short downtime windows are a reminder that modern space exploration depends not only on spacecraft in orbit, but also on resilient software, archives, and networks here on Earth. Thanks to our sponsor, 11 Labs. 11 Labs lets you discover the future of AI audio with cutting-edge voice technology. Find the link in the episode notes. That's it for today's Space News Survey. From evolving dark energy to delayed launches, and from Mars flybys to server maintenance, today's stories show just how interconnected modern space science has become. Join us next time for another AI-generated briefing from across the cosmos.